In this video, we want to work out how we can use Pythagoras' theorem to solve some problems. So no matter if it's in 2D or in 3D, what we're trying to do is find some right-angled triangles so that we can use Pythagoras' theorem to solve for some unknown side. So if we look at this 2D problem that we have right here, what we've got is we've got Lee's home down here in the bottom left, and we've got the basketball court up here in the top right. And what we want to know is how far it is to get from here to here. So what we need to be able to find is some kind of right-angled triangle. Now in this situation, where you've been told that on the left-hand side over here that the height up to the top is 10 meters and the height across is 30 meters. So what we've essentially got there is we've got two perpendicular distances, that is two distances at right angles to each other. We can use those to solve this problem. So let's start solving this problem. What we want to do to start off with is we want to redraw the problem, but using a very simple diagram that only shows all the information that we need to know. So what I'm going to do is I'm going to draw the vertical distance up, the horizontal distance across, and then the distance to the house that we wanted to find. So again, this distance here was 10, this distance here was 30, and this distance here is the one that we want to find out. As we can see, these two distances up here, these were the ones at right angles to each other. Now again, if we're going to use Pythagoras' theorem, we need to know a right angle triangle is in play, and we need to have two of the three sides, so only one of the sides can be unknown. Now in this particular problem, we could mark that this was Lee's house and this here was the basketball court, but that's not entirely necessary for you to mark it. It's just helpful if you're trying to keep track of what's where. Now we can use Pythagoras' theorem. The square that would be on this side, the area would be 30 squared, which is 900. The area of this side would be 10 squared, which is 100. And then the area of the large square here would be those two added together. So 900 plus 100, which is 1000, which means the x here is going to equal the square root of 1000. Now, you can leave that in exact form by just leaving it just like that, or you could round it to a decimal by using the calculator. So square root of 1000, 31.62, or using the other calculator, the square root of 1000, 31.62. So x here is 31.62 meters long. If we had this problem here, where we want to find the distance from A to B inside of this rectangular prism, what I would need to do is find how far it is from this point here to this point here. Now, unfortunately, there doesn't seem to be any obvious right-angled triangles in this diagram. So what I can do is I can make one. If I draw a line from this point here A over to this point here D, what I have created is a right-angled triangle from A, D, and B, and that makes a right angle right there. So this angle in the corner here is a right angle, and I now have a right-angled triangle that I can use Pythagoras with. Unfortunately, to use this triangle, I would need to know both this length here, the 3, which I do know, but I'd also need to know this length here, the length from A to D. Unfortunately, I do not know that length, but I can find it out. If we want to find what this length here is, we're actually going to have to use Pythagoras again with a different triangle, and that triangle is the triangle ADC. So it's another right-angled triangle in this diagram, as we can see if we do this angle right here. This angle is another 90-degree angle. It's another right-angled triangle, but if you're looking down from the top, that is the right-angled triangle. So we can use this triangle to try to find the length of AD, and then once we know the length of AD, we can use that and the length 3 to find AB. So let's go over and do that right now. So here is the 3D diagram again, but we want to be able to make a nice simple 2D triangle that we can use Pythagoras' theorem to find a length of. So again, we're going to have the triangle ABD. So we've got A in the bottom right corner here, we've got B up in the top. This distance is the one that we want to find. This distance right here. And then D is just that point in the bottom. This is a nice right angled triangle. We can use this to find the length of X. But to find the length of X, we need to know this side length here, which is 3, but also the bottom side length here. Now we don't actually know how long that bottom side is at the moment, so let's just call that Y for now. If we have a look at the top view of the diagram though, we can try to work out what that length Y is. So again, Y was the length AD, which is from the bottom right corner up to the top left in this diagram. So again, we redraw the problem, but just drawing the important parts. So nice triangle. This is the top-down view. This is from A to D, and then this point here is C. Now, this length on the bottom here, we actually know from the diagram is 5. This length at the side was 3. We can now use Pythagoras' theorem to find the length of this side here, which again was Y from earlier. So we can draw the square. The area of this one here is 5 squared, which is 25. Area of this one here will be 3 squared, which will be 9. All right, so now let's try to use Pythagoras' theorem to find what Y is. So we're going to have the squares on all the sides. The area of this guy here is going to be 3 squared, which is 9. The area of this one will be 5 squared, which is 25. The area of this one is going to be 9 plus 25, which is 34, which means Y will equal the square root of 34. Now that is not a nice number, so I'm going to just leave it as that. Now we can go back to the original problem we had, but now we know that Y is the square root of 34. So now we do the same thing again, but with this diagram here. So again, we can do 3 squared, do this number here squared. Now, if you square a square root, you could just go end up with a number on the inside. So all right, now that we know that that value Y from A to D is the square root of 34, we can now find the length of X, which is the original problem we wanted to solve. So again, so now that we know that Y is the square root of 34, which is again that length of A to D, we can now use that to find the value of X. So let's use Pythagoras. We're going to find the area of these squares. The area of this one on the left here is going to be 3 squared, which is 9. The area of this one is going to be the square root of 34 squared. Now those are the opposite to each other, so that just gives us 34. And the area of this one up here is going to be a 9 plus 34, which is, of course, 43. That means that X is going to be the square root of 43, which is approximately, if we want to use our calculator, we want to do the square root of 43, which is 6.56 if we're running 2 decimal places. So 6.56. So using Pythagoras twice, we were able to find that diagonal distance through that cube there.